myself Sharan Kumar Varda. Here we are here to present our topic classification of magnetic materials. So before coming to the classification of magnetic materials, I'll be speaking on the introduction part, like what is magnetic material. So magnetic material are those materials in which the state of magnetization can be induced, or in other words, the material which can be magnetized are known as magnetic materials. Example: iron, nickel, cobalt, steel, aluminium. So when piece of iron is brought near to the magnet, it gets magnetized and starts acting like a magnet. So coming to the classification of magnetic materials, before so all substances show some kind of magnetic behavior, and after all they are made of charged particles like electrons and protons. So it is the way in which the electron clouds arrange themselves in atoms, and how a group of these atoms behave, that determines the magnetic properties of different materials. So to study the magnetic properties of magnetic materials, the material is usually placed in a uniform magnetic field, and then the magnetic field is varied. So there are three major kinds of magnetic materials: diamagnetic materials, paramagnetic material, and ferromagnetic materials. So coming one by one, diamagnetism is explained by Srinivas. So Srinivas is going to explain diamagnetism.
Hello guys, I'm Srinivas. I'm going to explain about diamagnetism and diamagnetic materials. Diamagnetic materials are the materials which are weakly repelled by magnetic field. The resultant magnetic momentum in an atom of diamagnetic material is zero. Here we see some properties of diamagnetic materials. They do not have a permanent dipole moment. Magnetic effects are very weak and hence often masked by other kind of magnetism. Diamagnetic materials are repelled by a magnet. The substances are weakly repelled by field, so in an uniform field, these substances have a tendency to move from strong to a weak part of the external magnetic field. The intensity of magnetization is very small, negative, and proportional to the magnetizing field. The magnetic susceptibility is small and negative. The relative permeability is slightly less than unity. Diamagnetic materials are independent of temperature. These materials do not obey Curie's law. The magnetic dipole moment is small and opposite to magnetic field. Some examples of diamagnetic materials are copper, zinc, bismuth, silver, gold, antimony, marble, water, glass, NaCl, etc. The next topic is taken by Samarth.
So hello guys, I'm Samarth and I would like to continue with the paramagnetism. Paramagnetism. It's a form of a magnetism whereby some materials are weakly attracted by externally applied magnetic field, and it also forms internally induced magnetic field that is also in the direction of magnetic field. The atoms with incompletely filled atomic orbitals, they form the paramagnetic materials. These materials unpaired electron in those atoms in the outermost electron orbit. Here we can see some of the examples for the paramagnetic materials, that is hydrogen, lithium, boron, carbon, nitrogen, etc. etc. These materials have permanent dipole moment, and these substances, when the magnetic field is removed or in the absence of the magnetic field, these tend to lose their magnetism properties. The paramagnetic materials, these are further classified into the two types. There are low concentration magnetic moment materials. These are called as paramagnetic materials. Then high concentration magnetic moment materials. These are called as ferromagnetic materials. Coming to the properties of the low concentration magnetic moment materials, it is paramagnetic. These are called paramagnetic materials. The net dipole moment in these type of materials is not equal to zero, because the unpaired electron in the outermost orbit does not make it zero. Then these substances are weakly attracted by the magnet. In non-uniform magnetic field, these materials, they tend to move from weaker region to the stronger region of magnetic field. Then the intensity of the magnetization is very small but positive. The magnetic susceptibility is small and it has a slight positive value. The dipoles are arranged in the direction of magnetic field, whereas in diamagnetic they are arranged opposite to the direction of magnetic field. The magnetic line become denser when they enter the material and they become weak when they come out of the material. Hence it is proved that the intensity of magnetization in the material is high. The relative permeability of these kind of materials is slightly greater than 1. Then the magnetization is inversely proportional to the temperature. That is, this is the statement from the Curie's law. It states that as the temperature increases, the magnetization decreases. This will be discussed with you in ferromagnetic substances. Then the ferromagnetism, which will be discussed by my friend Sirish.
Hello. Thank you so much. Now, myself Suresh. I'm going to explain about the ferromagnetic materials now. What is ferromagnetic materials? There are various kinds of magnetism, out of which ferromagnetism is the strongest type. Ferromagnetic materials are those materials which exhibit a spontaneous net magnetization at atomic level during the absence of the external magnetic field. When it is placed in the external magnetic field, ferromagnetic materials are strongly magnetized in the direction of the field. Ferromagnetic materials are strongly attracted to magnet. These materials will retain their magnetization for some time even after the external magnetic field is removed. This property is called hysteresis. And the major cause of ferromagnetization materials are in ferromagnetic material is in unmagnetized state. The domains exhibit a net magnetic moment even in the absence of the external magnetization field. Now let us discuss about the properties. The atoms of ferromagnetic substances have permanent dipole moment present in domains. What is domains? Atomic dipoles in small is called domains. Okay. The magnetic dipole moment is large and in direction of the magnetizing field. The magnetic sensibility is also very large and positive. Okay, the magnetic sensibility is equal to the intensity of the magnetization by the strength of the applied magnetic field. When relative permeability is also very large and varies with linearly with magnetization field. When ferromagnetic material is liquefied, it loses the ferromagnetic properties due to high temperature. Then the examples are the most of the ferromagnetic materials are metals. The common examples of ferromagnetic substances are iron, cobalt, and nickel, etc. So and so. Besides, the metallic alloys are also classified as a ferromagnetic materials. Then the uses of ferromagnetic materials are they are widely used as in industries. They are widely used in devices like electric motor, generators, transformers, telephone, loudspeakers, etc. etc. Now, our Apache will explain about further topics. Thank you.
Hello, I am Sarvesh. I am going to talk about antiferromagnetic and ferrimagnetic materials. In materials that exhibit antiferromagnetism, the magnetic moment of atoms or molecules usually related to the spins of electrons aligned in a regular pattern with neighboring pointing in opposite directions. Antiferromagnetism is a process in which the forces acting between two adjacent atomic dipoles have signs opposite to that of ferromagnets. Now let us move on to properties of antiferromagnetism materials. In simple words, in a pair of atoms, the moments are arranged in such a way that they cancel out each other. That is, if one is upwards, the other will be downwards. Thus, antiferromagnets, the net magnetic moment in the of the substance is zero, as the alternate orientations of moment cancel out each other. The antiferromagnetic nature can be destroyed by heating at higher temperature. Now let us move on to ferrimagnetism, materials in which the magnetic dipoles of the atoms on various subset are opposed, as in antiferromagnetism, but the opposing moments are unequal in ferrimagnetic materials, leaving a random net magnetization. Now, properties of ferrimagnetism: high resistivity and anisotropic properties characterize ferrimagnetic materials. A microwave pulse circulatory polarized in same direction as the precision. For example, interacts intensely with the magnetic dipole moment when polarized in opposite direction. The effect is negligible. Now conclusion is being taken by Sharon.
So the introduction and classification of magnetic materials has been discussed and presented. So we saw what are magnetic materials and the types of magnetic materials by classifying them. And here we end this presentation. The team is thankful for providing this opportunity. Thank you.